Hi everyone, welcome again to my channel wiki-knowledge. Today, as my first video, I'm going to talk about one thing that made a lot of noise these days. And as you know, it's the first published image of a real black hole. But before talking about the image, we need to have an understanding of what is a black hole, what is inside of it, what is outside of it, and then know why that image is important for us. So first, what is the black hole? A black hole is a region of space which anything that falls into it gets trapped inside. Okay? Even light, as the fastest moving thing that we know, can't escape gravity of a black hole and gets trapped inside. But here comes a question. If light can't escape its gravity, how do we see it? How do we take picture of it? Actually, we don't. We don't see the black hole itself. We haven't taken the image from black hole itself. The image taken is from surrounding the black hole, outside of the black hole. If a black hole is surrounded by matter, it will try to pull that matter inside. Matter getting inside the black hole will gather around it and create a disk called accretion disk. The molecules of gas and matter inside that disk circle so fast that they heat up and emit X-ray. Those X-rays here on Earth are detected by scientists, and they find that there must be something on that region, okay? And it could be a black hole. Now, what is inside the black hole? In theory, general relativity says that inside the black hole there is a gravitational center called singularity. Singularity is a one-dimensional point which contains huge amount of mass. Okay? And as you know in physics, if smaller objects contain higher masses, density on those objects would be high. And here that we have a point with huge amount of mass, density is infinite. Okay? Around this point, there is an area that anything falls into that area gets trapped inside. That area has a criteria, which is called event horizon. Beyond that event horizon, everything is visible for us. We can see it, we can take picture of it, but inside the event horizon, nothing is visible, and we don't know what is happening there. It is a point of no return. Okay? Now we know what is black hole, what is inside of it, and what is outside of it. Let's talk about our image. First of all, to capture this image, more than a century of scientific work, more than 200 scientists, 2 years of planning, and 20 countries have been collaborated to get this image. But how did they capture it? To capture an image of something in that distance, scientists needed a telescope as big as our whole planet. Let me first say that this black hole had 55 million light years distance from us. It is like looking at something, looking at an orange in the surface of moon. Okay? To take a picture of that, we needed a telescope as big as our whole planet. But that is impossible, as you know. So scientists came up with an idea. They have combined and they have used 8 different radio telescopes from all around the world, okay, to get data and image at the same time from one thing. They come up with some ways to combine those data and get this image. So they have used 8 different radio telescopes and created a network of radio antennas to get our image from that black hole. But why is this image that much important for us? First of all, it is the first image taken from a black hole. Before this, we just predicted that there are black holes, there are event horizons, but now we really see those event horizons and black holes, okay? Second, again, it proves general relativity for us. And it's not just that. With this image, there are a lot of informations and data gathered, okay, which is being analyzed right now. By analyzing those data, scientists can tell us many things. For example, by analyzing dynamics of stars around the black hole, they can give good estimations of black holes' masses. Okay? They couldn't do that before. By analyzing those data, they can give us and reveal the origins of black hole flares, which in this case our black hole has flares, and those brighter areas that are you see in the image are flares that coming toward us. Okay? By analyzing those data, again, scientists can tell about the polarization of black holes. Do they have intrinsic magnetic fields or not? And many other things that could be reached by analyzing those data. For conclusion, let me say that this image and data coming with it will open doors of black holes to scientists, will let them explore black holes. Even it will let scientists learn about our universe, how it works and how it goes on. So that is why this image is so important for us, and that's why it made this much noise. I'm gonna finish this video here, and if you want to learn more, I maybe write some posts about general relativity and singularity later, but you can also learn about black holes and singularities and other things in good references that I will try to give you. Thank you for watching this video. Hope you've enjoyed it and learned something. If you had any questions or suggestions, feel free to comment. I'll be reading all of them. Thank you for watching.